Welcome. Welcome to Writing Algorithms. This is computer studies for grade 9, but grade 10 can also benefit if you want to revisit algorithms. This would be an introduction to writing algorithms. This video is part 1, so be sure to be on the lookout for part 2. Using algorithms as a problem-solving tool. Designing solutions to computer-based problems. Our objectives in part 1. Understand the term algorithm. Have the ability to design a set of steps to solve a given problem. Rewrite the steps into a proper algorithm. Test the steps. So you can copy these down, and as you proceed with the lesson, you can tick them off to see which ones you have mastered. If you find one that you haven't mastered, feel free to go back in the video and redo those specific steps. It is impossible to do 4 things correctly at the same time. We will therefore concentrate on each step, one at a time. In this unit of work, you will learn how to design programs that make a computer perform some simple tasks or solve simple problems. If you sit down in front of a computer and try to write a program to solve a problem, you will be trying to do 4 out of 5 things all at once. What are these 4 out of 5 things that you are going to attempt? Analyze the problem, design the solution, code or enter the program, test the program, evaluate the solution. Now, the evaluation of the solution comes a little later. What I'm trying to explain is we need to take these one by one. You can't tackle them all at once. So you can't take a given problem and think, okay, I'm going to take my computer and just write a program. It doesn't work like that. You need to analyze first. So that's the only step you do in the beginning. After you finish your analysis, you need to design the solution. After the design of the solution, you are going to code, and then you are going to test. And after the testing, you will evaluate your solution. Evaluate meaning checking to see if it's actually doing what it was intended to do. Analyze the problem. We are going to look at the steps. First one, analyze the problem. When you analyze a problem, you look at the problem in front of you and decide what you need to do to solve the problem. You design a solution or a program. Program design is the most important part in producing a computer program. This is the stage where you decide how your program will work to meet the decisions you made during the analysis. So design cannot come first. Analysis would be first. Program design does not require the use of a computer. Read that again. I put it in bold. To design your program, there's no need for a computer. You will carry out your design using a pen, pencil, and paper. In your design, you will use a method called top-down design. In using this method, you simply write down the steps in the correct order from the top downwards, from the beginning towards the end, that you are required to perform to solve the problem. When all these steps are put together, you have what is called an algorithm. An algorithm, step by step, set of instructions for solving a problem in a limited number of steps. The instructions for each step are exact and precise and can be carried out by a computer. Read that again. It's a step-by-step set of instructions for solving a problem in a limited number of steps. The instructions for each step are exact, important, and precise. You cannot assume anywhere in an algorithm. You need to be exact and precise so that it can be carried out by a computer. Creating an algorithm. To begin with, we look at 3 methods used in creating an algorithm. These are stepping, looping, and choosing. Stepping, you use a set of steps. Looping, a loop, something repeats itself. And choosing, decisions. Now stepping out. First of all, we will look at the method of creating an algorithm called stepping. This is where all the instructions needed to solve our problem are set out one after the other. Here are some examples. Let's assume our problem is to find the sum of 2 numbers. You know the sum would be adding them together. So what would your steps be? Just written steps. You're not in algorithm language yet. You're not in high-level language yet. You're not coding yet. Just the steps. We are analyzing. Step 1. Add the 2 numbers together. Step 2. Write down the answer. These 2 steps would effectively find the sum of 2 numbers. Let's look at another problem. The problem, to change the temperature in Fahrenheit to centigrade, which is also degrees Celsius. Now you have to know this formula to go from Fahrenheit to centigrade. The formula is step 1, take the Fahrenheit, subtract 32. From that, multiply that result in step 1 by 5. Divide the result in step 2. So you found a result there. You are using it, multiplying it by 5. This result you will divide by 9 and then write down the answer. For both these examples, list the algorithm in ordered set of steps. That means they are ordered. Subtract doesn't come at the end and write down the answer at the top. Now, it's your turn to try a few of them. Try this one with me. I'm first going to explain those 2, and then you will try the ones after my explanation. You can pause your video and copy the solutions to these problems that we already discussed now. The one for finding the sum of the 2 numbers and the second one for changing the temperature. After this screen, you will get your instructions on how or exercise that you can solve. And you will be provided with the answers afterward. Carefully look, we have to start. We initialize sum, num1 and num2. Enter the first number, enter the second. Sum now becomes the first number plus the second one. And then we output, labeled output. When we use these inverted commas, it means this will be typed on the screen. This will be text and the value of sum. So this is our initialization. This is the input stage. This is the processing stage and the output stage. Problem for Fahrenheit to Celsius or centigrade. We give temperature an initial value of 0 and centigrade an initial value of 0. We enter temperature. We use any method that the user can use when they use a computer program. That can be escape, cancel, star, any key. And that will enable the person to stop the program before the program started. I will look at Sentinel values in deeper context a little later. So this is the input stage together with the Sentinel value. Centigrade now becomes temp, which was entered, minus 32, multiply by 5, divide by 9. This is your process. And then we have to output temp. So the value that temp received there, or that you input there, will be shown there. And the text in Fahrenheit is equal to, and then the value that was the result in centigrade there will be placed there, and the word centigrade afterwards. So if we should test it, sum of two numbers, let's use 4 and 9 as our test data. Step 1, everything was set to 0. Step 2, enter the first number, 4. Step 3, enter the second number, 9. Step 4, add the two numbers and get the sum. 9 plus 4 is 13. Step 5, output with labeled output. Do you see I don't use inverted commas when I show my output? This is when we program. This is the actual output. The sum is 13. You might pause your video and copy down this solution. Second problem, Fahrenheit. We already know what the algorithm looks like. Testing it. Step 1, everything set to 0. Step 2, enter the temperature. We got test data for 300 in Fahrenheit. Calculate the centigrade or Celsius. So this would be simple substitution. 300 minus 32 times 5 divided by 9. 300 minus 32 times 5 divided by 9. The answer 148.8. Step 4, output. The value of temp in Fahrenheit, value of centigrade were those words. 300 was the value of temp in Fahrenheit is equal to 148.8 is the value of centigrade Celsius. So your final output will read 300 in Fahrenheit is equal to 148.8 in centigrade or Celsius. Your exercise. The answers will be given to you in the next lesson. It'll also be provided on the different platforms. In your book or your exam pad, write down an algorithm for each of the following problems. Copy the problems first. Then below each problem, do your planning, your steps. Then compile and write your algorithm. Use the given test data to test your algorithm. There will be an assessment activity placed on the Google Classroom and other URLs which will be provided to you where you can type your answers. First problem, find the average of 4 numbers. Second problem, change time into in seconds to minutes. Third problem, find the product of 2 numbers. Change a volume in milliliters to liters and find the difference between 2 numbers. In red, you will find your test data. Happy learning.